Good evening, young people. This is Mrs. Rains. We're going to be talking about measurement and why we measure the way we measure and some things that you need to know about measurements. So here we go. So measuring instruments, instruments that we use for measuring volume are as follows. We have a graduated cylinder. We could use syringes if we need to. Something called a burette. We don't use it very often in our class, but we do use it in AP chemistry. It looks like a graduated cylinder with a little syringe tip on it. We have pipettes. We have small plastic ones, but we also have ones that are volumetric and transfer pipettes. And then finally a volumetric flask, which is something that we don't use very often in our advanced chemistry class, but we do use it in AP chemistry. So just to make you aware, the smaller the instrument gets, the more accurate the instrument gets. So you can see as we get smaller and smaller, we get less graduations and more just marks that give you accuracy. So this is the one we use most often. We use a graduated cylinder. This is an example of a 100 milliliter graduated cylinder. Okay, units of measuring. We measure in liters or milliliters. They talk about a quart equaling 946 milliliters, but we don't measure in quarts in science. We measure in liters and milliliters. Milliliters would be the small unit, liters would be the big unit. Okay. Reading the meniscus, so when you put liquid into a graduated cylinder, because it's a cylinder, that liquid has some properties that allows it to make a curvature. In this case, the curvature is concave and not convex. Concave meaning that it caves in, convex meaning that it bubbles up. So what we see is this. We see this curve right here. Okay, what you don't want to do is look at the curve from the bottom, because then you'll read wrong. You also don't want to look at the curve from the top, because again, you'll read wrong. What you want to do is you want to look at the bottom of the curve, and this would be the correct way to read it. You have to get at the level with the graduated cylinder sitting on the counter to read the meniscus properly. So it's always flat on the counter. You are looking at the eye level right at the bottom of the meniscus and trying to read with the proper sight. Instruments for measuring mass. We can have a triple beam balance, or we could have an electronic balance. We use electronic balances more often in this class. They're quicker, they're faster, they are more expensive, but a little bit more reliable in terms of what we get. Triple beam balances can be hard to operate, although they're not really hard. You just slide the little beams around until it all evens out. I learned how to use one. I taught how to use one for years. We just don't have enough that are usable to transfer between the buildings. Okay, units for measuring mass. We use kilograms and grams. Pounds, though, are something that we're familiar with in this country, but we don't use pounds in science. We use kilograms and grams. So we're always going to go with the SI unit here, kilograms and grams, never pounds. Instruments for measuring temperature. These are the three things that we measure most often: volume, mass, and temperature in this class. So we could go high-tech here with the probeware, and we have a vernier probe that actually hooks into some probeware that we have. Or we can have just a pocket thermometer right here like you see here that we put into things and we get an automatic displayed reading. The vernier probe needs a little bit more. We have to plug it into something, a calculator or a computer, something like that. Or we can go the old-fashioned alcohol thermometer. Those work too, and in a pinch, we use them. Okay, units for measuring temperature. We have 3 units that we can find temperature in. In our country, we measure temperature in Fahrenheit almost exclusively, but in science, we measure temperature in Celsius, and we have another temperature scale that will be introduced if we get to gas laws called Kelvin. The Kelvin scale has no zero or no negative numbers. There are no negative temperatures on the Kelvin scale, and so that's the beauty of the Kelvin